Welcome back to another video. My name is Michael. I'm the founder of Buffalo Performance and Analysis, where we combine sports science, strength and conditioning, and sports performance to give coaches the tools necessary to build the next level of elite athletes. In this video, we're looking at the soccer performance data that I posted to Kaggle, and we're looking over our workout routine dirty, which has some new variations that make creating a first sports science project a little bit more interesting. So let's go ahead and break it down and look at the data that we have collected. So we have the date, we have the name of the player, and one of the new ones that I added to the dirty data is the position of the athlete. And then like we had in the previous one, we have the session type, so whether it was a practice or a game. We have sleep duration, which is going to range between, I think, 5 and 10 for the most part. And then we have a sleep score, which is going to be something that you would gather from like a Whoop watch or an Oura ring that's going to be reflective of the sleep duration. And then we're going to have four subjective measures. So we're going to have sleep quality, soreness, stress, and RPE. Those hypothetically could range from 0 to 10, and those are all self-reported by the athlete. So they're reflective of the previous day's training. So sleep quality is how did they sleep that night before. Soreness, how sore are they from practice the day before. Stress and RPE, same thing. There are some missing values in this data set, and that kind of gives the sports scientist or data analyst a little bit of leeway with how they want to interpret the data. RPE is a new value that I added. It's going to range, like I said, hypothetically between 0 to 10, but most values lie between 4 and like 8. Then after that, we have the distance covered. I was able to structure it in a way where the distances during practice is going to be slightly lower on average than the distances covered during a game. So you should be able to see that difference if you're looking at practices versus games. After that, we have the acceleration count. So how many times did they accelerate above 3 meters per second? And then we have their max acceleration. We have the same thing for decel, decel count, and then max decel. And then we have the max speed covered by the athlete. The next two are new ones that I've added. We have injury or illness, and then injury illness type. So whether or not the athlete has an injury or some kind of illness. And we can go ahead and run a filter. I'm going to show you here really quickly. So we have 7 injuries or illnesses, and we can see the injury or illness type. So we have 2 pulled hamstrings, 2 calf strains, an ankle sprain, and then 2 guys were out sick. So those are some of the big changes that I made to the workout routine dirty that is still available on Kaggle for you to download and kind of play around with. I also added more variation between those subjective measures, so the sleep quality, soreness, stress, and RPE. I went through and kind of gave a little bit more variability. If you ran a correlation coefficient in the original data set, there's going to be a really high correlation between like distance and RPE, and like a 0.95 correlation is not realistic. So I went through and I tried to mix up the numbers to bring the correlation down a little bit, but still be reasonable data. So I wanted to kind of show you here that we have RPE and distance. We have a correlation coefficient of 0.81 or 0.82 really. Then looking at soreness and distance, 0.76, and then sleep or stress and sleep duration is a negative 0.84, 0.85 correlation. So a little bit more variation, a little bit more room for interpretation. I'm also giving some leeway, right? So if you have outlier data points, what are you going to do with those? Are you going to just keep those in and run your correlations there? Or are you going to drop outliers and then run your correlation there? A lot more leeway, a lot more room for a sports scientist or data analyst to kind of grow and explore this data set. And that's exactly why I created it, for young or entry-level sports scientists to have their hands on data that's relatively reflective of real data that you would find from soccer athletes, and be able to quantify it and be able to create something in R or Python or create a visualization using Power BI So I really wanted to create something and put it out there for sports scientists to have and get their hands on and practice with. So if you like the video, please give it a thumbs up. I'm going to be making a Power BI dashboard tutorial looking at how we can use this data set to create our own visualization. Thanks.